So guys, as you can see, this is our HC-05 module, and this over here is the PIC16F877A microcontroller. Now, see that on a mobile phone, this Bluetooth module is sending PIC waiting. PIC is waiting. Now what I do is that I send an A. So I send an A. Once I send an A, now see it starts a counter 0, 1, 2, 3. It's going from 0 to forever. It will go to infinity. See that? Now to terminate this counter, what I do is that I send a B. See? Now I write B, I send it. Now when I send a B, it got terminated. Now again I send an A. It will again start the counter. See? And when I send B, it terminates the counter like this. See? It is working like a charm. So we are using our smartphone to control the operation of a PIC, like we are running a counter or terminating a counter. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can use a PIC16F877A to generate a counter and use a smartphone to display and control it using HC-05 Bluetooth module. So we will be using a Bluetooth module connected with the PIC16F877A. Then we will be using our mobile phone to start a counter and then to stop a counter wherever we wish using our phone. So in this way, we will be controlling the counter generated by a PIC using our smartphone using the Bluetooth module. So let's get started. So guys, this over here is the PIC16F877A microcontroller having 40 pins. It's a TIP version. This over here is a HC-05 Bluetooth module. So let me label it for you before we move on. So the bottom pin next to the button is the enable, or sometimes it is called the key pin. And the upper one is a VCC, then ground, then TX, RX and state pin. Now before you use this module, you have to do the settings. And I have a video on that, how I did the setting for this module. I will share the link to that setting up a Bluetooth module video in the link in the description. The link of that video will be in the description of this video. So you can watch that video before you watch this to set up the Bluetooth module. Now guys, let's connect it with the PIC. Once your Bluetooth module is set up, then you go to the normal mode and you set up to the PIC like this. You connect the RX pin of your Bluetooth module to the TX pin of your PIC, and the TX pin of your PIC is the pin number C6, that is pin number 25 of the PIC16F877A microcontroller. And the TX of the Bluetooth module will go to the RX pin of the PIC, and the RX of the PIC is pin number C7, that is pin number 26 of the PIC. Now guys, in this way your TX will go to the RX and RX will go to the TX. Now for the ground pin, connect it to the common ground of the PIC like this, and for the VCC pin, just connect it to the VCC pin of the PIC. The supply which will be powering up the PIC will also be powering up the Bluetooth module because it requires very low current and voltage to operate. It's the 5 volt and current is like maximum of 50 milliampere. So in this way, our both the devices are powered up. Now guys, let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. This is the Bluetooth module. This is our PIC16F877A. The rest is just a trainer board, and this is a cell phone I'm going to use to connect to the Bluetooth module over the Bluetooth channel. So guys, this is a simple hardware I have here. So what I do is that now let's move on to the MikroC for PIC programming and write our counter, and then we will initialize the Bluetooth module and send the data to the PIC or to the smartphone using the PIC. So let's get to the MikroC for PIC. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. So guys, the version I have over here is 7.6.0. You can use the latest versions as well if available. I will share the link to the video in which I told you how you can download and install MikroC for PIC latest version from the official website legally without any crack or other illegal stuff. Directly from the website, full final version without any cost. I have a video on that and I will share the link to that video in the description. Now go to the file, new project. This window pops up, new project visit. Click on next, write the name of the project. I write here Bluetooth controlled counter using PIC16F877A tutorial by learning microcontrollers. That's the name I wrote. You can write any name as you want, and this is the folder where your files will be generated. and select the microcontroller you are going to choose. I am going to use a PIC16F877A, and the clock I have is 20 megahertz. You can see whatever the crystal is at the pin number 13 and 14 of the PIC16F877A, you will write that crystal value over here. Since PIC16F877A don't have an internal oscillator, so only the external will be written here. Click on next, write the name of the project. It's done. Now just click on finish. No, nothing else to write. Now this window pops up. First of all, what you do is that you press Ctrl S to save your work. Like this, save the work. Now first of all, we will need to initialize our UART module because the HC-05 we have works on the UART port. So to initialize the UART port of the PIC, go to the right. In the right, MikroE libraries, expand it, expand the system libraries. Go to the bottom, you have this UART, check mark this. Now go down in the library of the UART, you will find this UART init command. Double click on it. This window pops up, and in the example here you have this command UART1 init 9600. Now what you do is that you go to the one-time loop, paste it here like this, and now this command over here initializes the UART port of the PIC on which your HC-05 is connected. So in short, it will initialize the HC-05 module. What I write here initializes the HC-05 module. So that is what this command is doing. And now at what baud rate? This baud rate, I have a video on this HC-05 module in which I taught you how you can set this up. So whenever your HC-05 module is in the setting mode, then you set the required baud rate. The baud rate I set was 9600. By default, it is also 9600. So during the setting, if you change the baud rate, then you have to write that baud rate over here. So my baud rate is 9600, so it will do fine here. Now I give some initialization. Delay not necessary, but I always suggest you give it in that one-time loop. 100 millisecond will do fine. Now our UART port is initialized, and in short our HC-05 module is initialized. Now we can go to our forever loop. So you write here delay ms as well. It's millisecond. So now we go to our forever loop. So for the forever loop, write down while 1. Forever loop will start here and will end here. Remove the space, make it look presentable like this. Also give a space here like this. Now guys, what we do, first of all, what we do is that our UART module is initialized. Now we need to do is that we need to write commands that what we are receiving from the PIC. Our PIC will be controlling the counter. So first of all, we need to get the commands from the PIC, what to do. So to get a command from the PIC, we go to the right in the UART library. You have this command UART1 read. Now whatever the data is sent from the HC-05 module, from the Bluetooth module, we will get to using this command. Just copy this from the UART read library, copy this whole structure in the example, paste it here like this. Now here you know this command over here, if UART1 data ready, sees if the RX buffer of your UART module is ready to receive the data, then whatever the data is received will be read by this command. UART1 read. This command can read only 1 byte of data, that is a char, a single char. So we need a variable which can store a single char. So I go above the void main and I initialize the variable char read1. That's what I name it. So whatever the value will be sent from the mobile phone over the UART, over the Bluetooth, that will be received at the receiver HC-05 connected to the UART port of the PIC, and then whatever the char is sent will be read by the PIC and will be stored in this read1 variable. Now what we do is that we need to write the counter. So suppose we send a char double equals to A. I have sent an A from the smartphone. Then what should happen? What should happen is that now what we want is a counter. Now we make a counter because suppose an A is sent, now we will generate a counter. So to generate a counter, we will need another variable which will generate the counter. So I write integer. Integer is fine. We don't need to go to decimal places. Integer a count. We take a count variable. So count equals to count plus 1. That with every repetition, count will increase by 1. This will be our counter. So now if the counter will start, now you can use a for loop here, whatever the loop you prefer. What I will do is that I will simply make a forever loop here, while 1. So if A is received, then the PIC knows that A is received of the Bluetooth means that start a counter. It will start counter. Now the counter has started forever. Now it will keep on running until it do not get to some maximum value where the PIC gets reset. So what I do is that we need to display this over back as well. Now we are able to generate the counter, but counter is not displayed anywhere. We need to display it back on our smartphone over the Bluetooth. Now to write it back, I go to the right in the library. I have this command UART1 write text. Double click on it. This command over here, just copy this command UART write text output. This command will write the data back to the smartphone over the UART channel. Now I write it here. Now the problem is we cannot send like these integers directly over the UART channel. We need to convert it to a string. Now to convert this integer count to a string, we need to use a conversion library. Now go to the right, go up. Here you have this library called conversion. And inside the conversion library, you have this command called int2string. Double click on it. And this command over here, you copy it, integer to string, and paste it here. Now, whatever the variable integer is here, will be converted to a string and will be stored here. Now, we need another variable which will store the converted integer value. Now, I make an array of char. An array of char is a string. I call it scount like this. And maximum character it can have is 8. So, it's an 8-bit variable, scount. So I copy this, I paste it here like this. Now this is how you can use this command, integer to string command. Now what the integer to string command will do, whatever the integer variable is here, having integer value will be converted into a string and will be stored in this string variable. Now we can send the string over the UART channel. So I paste it here. Now UART write text will send back whatever is here. Now initially our counter must start from 0. Now to make it 0 initially, we go to the one time loop and we write here count equals to 0. Now once the code starts, the counter is 0 by default. Now guys, the next thing is we have written the data. Now the data will be written very fast. It will keep on repeating. It will not go all over again. It will just go from here to here. Only these three commands will keep on repeating forever like this. Now we need to slow down the code so we can read it on our smartphone. I give some some delay to just slow down the code. Delay MS250. It means 250 millisecond delay, that is 1/4 of a second. After every 1/4 of a second, it will send the next value. So like by default it was 0. So we need to display the 0. If you need to display the 0, then bring it above this like this. Make these things come here. Now it is by default 0. Once it comes here, it will just convert the 0 to a string and it will send it over the smartphone. It will be 0. And then it will be incremented by 1. And then it will keep on repeating in the forever loop. And now we don't want it to keep on repeating forever. Now we how to break the code. Now to break the code, inside this forever loop, we will check again. Now we will use this command. Read one, that whatever the data is coming from the UART module, that is from the Bluetooth module, which is connected to our smartphone wirelessly using the Bluetooth channel. Suppose we received an A, we went into the forever loop. Now we are stuck here. We need to get out of it. Now again we will read the data in the forever loop. Now we will keep on reading the data. Now we are suppose again reading the data, and if this time read 1 double equals to B. Now a B is sent. Now our counter is working fine, but now we are tired of getting the counter. Now we want to actually evict the counter. I write the break command here. Now when we send the B, whenever we are in the forever loop, like whenever we are in the forever loop, this while one, the counter was running and I have decided that I want to terminate the counter. I will send a B, and once the B is received, it will break out of the loop. And once it breaks out of the loop, the first thing we must do is that we must reset the counter to the initial state. And this is the initial state. Initially the counter was at 0. So once we have broken out of the loop, I make the counter equals to 0, or I can just use the else here. Okay, suppose I have broken out of the loop, I write here else. Now this was the if, see, this is our main if. If we have received a A, then it went into the counter. Now else, if we have not received an A, then it will make the counter equal to 0 first, and then it will write a text that it is waiting. We also display a text like PIC waiting. I write here, just give 3 spaces, PIC waiting. Okay, it will keep on sending this, that PIC is waiting and counter is 0. Now another problem that is as per my experience, this read one is A. Once you make it A, it will remain A. So you have to give another character for resetting it. Like in the initial state, there must be some character which is not found in your code. So in my code, we are only using A and B. A to start the counter, B to terminate it. We are not using any other variable. So I have a lot of options. Now in the one-time loop, I write read1, that is the variable which stores the data coming from the microcontroller, from the smartphone. I make it something which is not in the code. That is not being used in my code. So initially it will be Z, like it will not affect the code at all. So that's how I'm going to keep my code safe. Now Z, now also in the else, here you place it here. Because if you don't do that, suppose you have sent an A. It goes here in the else. Now the A is in the read buffer. You have not changed the buffer. Either you clear the buffer or you use this, like you override the buffer with some character which is not being used in your code. So that was not being used. So I have just by default it will be as that at the receive buffer. So it will not affect my code. Now this is what is going to happen here. What we do is that now we build the code and check for errors. Okay, there are no errors. That's great. Now let's burn it into the microcontroller and see what happens. Let me turn on the PIC16 programmer tool. Let me zoom out some bit. Okay, there it is, our PIC16 programmer tool. I will share the video as well in the link, share the link to this video in the description as well, in which I have told you how to download and install this PIC16 programmer tool as well. I have a video on this as well. So go to the file, import the hex file you just wrote like this. Also select the microcontroller. I have PIC16F877A, F877A, this one, like this. And your file, you have to select the controller first, then the file. So select the file. This is the file. Okay, click on write. Okay, the new file is being written. Let's go to the hardware and see what happens. Okay, let it write the new file. Once it's written, we will turn on our mobile phone. Okay, the file is written. Now to check if it is working or not, I power up the circuit using the PIC3. I click on. Okay, the circuit has turned on. Now I just put up my mobile phone. See, the Bluetooth module is on. It is rapidly blinking, meaning that it is looking for a device. So I go to, let me log in. Let me remove any previous data. Okay, there are various apps you can use for this type of task. In the Play Store, Bluetooth related apps are many. So I have downloaded this serial Bluetooth monitor. I just open this. Okay, it's open and my device is already initialized. Let's go to these 3 pins. And first of all, you also have to turn on the Bluetooth as well. My Bluetooth is on. Password is already entered. I go to this devices, and this is the device, this is the name, and this is in my previous video in which I showed you how to set up your HC-05 module or do the setting of this module. I had shown you how you change the setting name and password of your Bluetooth module. So I will share the link to that video in the description. You can just learn from there. So I set the name to learning microcontroller and the password was learned, which is already entered. Now I click on it. Okay, you can see it is saying connecting to learning microcontroller. It is connected. Now see, it is sending PIC waiting continuously. So this is good. That is what we just programmed. Now what I do is that I go to this bar over here. Okay, and this keypad pops up. I click on A. I send an A because I programmed the A. Okay, here we go, an A. Now what I do is that I send it using this button. Oh, you see, it has started to run the counter. See, the counter is running. 1, 2, it will keep on running forever. See, it is working fine. Now I will send a B. B will terminate the counter as programmed. It must. So I send a B. See, the counter is terminated. Now again I send an A. Okay, again I send A. Okay, A is sent. It has again started the counter. Because PIC waiting is sent so fast that it keeps on sending at a very fast pace. Because it is not overwriting, we have a screen, it keeps on displaying. So you can use a different Bluetooth terminal as well. This terminal I think is very slow. Now you can see that again the counter has started. Now we are just controlling this counter from our smartphone. You can see that there is the HC-05 module and this mobile phone is totally in my hand. It is not connected to through wires. See, it will keep on running the counter, and the speed of the counter we have set is to 250 milliseconds. That's why the counter is readable, while waiting PIC is too fast because we have not given any delay to that, because once we send our data, the delay may cause the data to get distorted. Now what I do is that I again send a B to see what happens. So I send a B, again it has been terminated. Now I send A again. A, I send it, okay. Again the counter has started, see. Now I will not write D, I will write anything else. I write G because G is not programmed. See what happens. See, nothing happens. The counters keep on running. I send like I or anything else like B, not the B. K, what happens? Nothing happens because K is not programmed to terminate it. Now I send a B. B will terminate the counter. I again send a B. So the B terminates the counter. So guys, this is how you can use your smartphone using a Bluetooth module to do various tasks with the PIC microcontroller using the Bluetooth. Like you can control the functioning of a PIC wirelessly. It is working like a remote control. It will help you to make robots, drones, or small applications like monitoring systems, etc. And it has very great applications in industry and home automation as well. So guys, I hope this video gave you some insight to something. I hope you guys learned something from this video. Thank you very much for your time, guys, and have a nice day. We'll see you in the next video.